Welcome to the last part of my little CNC series. My machine is almost finished and just some small stuff is missing. Today I will show what is left and also an easy way to produce a milled object from a drawing using Inkscape. I just realized that I did not yet talk about the motor power supply. When I started this project, I thought that I need this badass 30 volts 5 amps power supply, which was previously used for LED applications. It turned out that I don't need that. My machine runs just fine on this 19 volt 3.5 amps laptop power supply that I had lying around. I gave my machine 5 switches that tell the electronics when one of the borders is reached. They are put in parallel for each direction. That's enough because the controller knows whether the machine is currently moving back or forth. So when a switch is closed, my software knows whether it's the minimum or the maximum switch. My software has a built-in test for the switches and it can perform a homing loop including max limit check. I have used some flat SMD LEDs to build a lamp and glued it under the tool holder. It is connected to the 19 volt power supply and goes on whenever I switch on the power for the motors. By the way, you might ask why I have attached all my sliders with the large piece up. The reason is dust. My sliders are under the workbed and so things could easily fall down and block my ball bearings. Removing dust is generally important while milling. I used a piece of plastic pipe to build the adapter for the vacuum cleaner. I have cut a spiral in this pipe and surrounded it with a piece of bicycle inner tube to get a flexible but stable hose. My drilling tool does not move in any direction besides up and down, so I can just place the hose close to the tool and attach it somehow. Now that everything is up and running, let's mill some stuff. The workflow is always the same. It starts with a drawing, which needs to be converted into G-code. This code is then checked and sent to the machine. There's many ways to create G-code from drawings. I focus on freeware tools here and most of them are available for Linux. With the graphic software Inkscape, I can create drawings and text. Basis for every milled object is a vector-based drawing, because we always need lines and strokes and so on. There's the Inkscape plugin called gcodetools, which I used for most of my examples. It is cumbersome to use at the beginning, but actually does a quite good job once you get used to how it works. I will demonstrate with a small new project. I want to create a logo for my local hackerspace and later on mill it into a piece of copper-plated board, and I'm using Inkscape for that. I start with writing the word. And I am selecting a font with a very thin line, and in this case it's called ZFSD. So let's take this. Now this is a piece of font right now and we have to convert it into a path. And I will also move it a little bit up. All this right now happened on layer 1 and that's important because I will add further layers now. Then we need 2 rectangles. One is around the text and it's supposed to be carved in a little bit, as deep as the text itself, and the other one will be on the outside and will be where the milling tool cuts through the material and basically cuts out the whole shape. And I want this rectangle to have round edges. This is surprisingly difficult in Inkscape. There's no single function for it, so we have to apply a trick. What I'm doing here is I'm telling the object that it has no filling but a stroke, and now I make this stroke really thick. I don't know, a bunch of millimeters. Yeah, let's say like this, and I say that it has has to have round edges. Now the outer area here has round edges, the inner area doesn't, and now we need to modify this further. We convert this object into a path and also its strokes into path, and now I can say break apart, and you can see that the object falls into two different objects. One is the outer object, the other one is the inner object. We delete the inner object and now tell the outer object that it doesn't have a filling anymore. You see it disappears, but it has a stroke. And now we can just set the stroke thickness very thin, and you see that I'm ending up having a rectangle with round edges. Now we need a second rectangle. I'm just checking whether I'm still on the right layer. Yes, I am, because this is where the object will be carved, like will be cut out, and I'm marking both of my objects and click on Align, Distribute and center them vertically and horizontally. Now we are almost done, but I want to have a small hanging loop here that can be used later on to attach the object to a keyring. So what I'm doing is I am painting a circle of, let's say, 8mm diameter, or let's say 7 should be enough. And now I want to have this loop more or less here with a hole in here. And what I'm doing now is I'm combining the two paths. So I'm marking this path, and I click on path union, and now we have the sign itself, we have the loop where I put a small hole in later on. And now that our first step is finished. Now we want to mill this and carve a little bit into the surface, the same for the inner rectangle, and we want to cut through the material in the outer rectangle, and I'm using the plugin gcodetools for that. Before that, I am actually creating the circle that will be the hole later on. I'm taking my little object here, place it more or less in the middle. So there's actually a problem with the letters, because when I apply my G-code tools to, for example, this letter E here, it will actually cut on the outside of the letter, which makes the letter more wide than it is supposed to be. So we have to apply a trick with these letters here, and for that I am adding another layer where I basically fill the letters with, with a filling. I'm starting with marking my letters, and now tell them that they don't have a filling, but they actually have a stroke. It should work like that, so you see that there's a thin line in the middle left of each letter. Now I can go to my fillings layer here and start filling my letters with new objects. And I have to do this very careful, that I actually fill the right object. Okay, this worked for the number 2, it worked for the L, it worked for my letter E, and for my V, and for the other two. When I now switch off my first layer, you can see that only the fillings are left over, and this is what I am going to apply the G-code tools on, and so it's not cutting on the outside anymore, but more is on the inside, so I'm getting relatively small cut letters. I'm actually moving this layer up, and I will rename that and name it cut through, and I will rename this carve in. And now let's see, now I want to move these certain objects to the right layer. So this one goes down. Like we want to cut through this, and when I look in the other layer, we want to carve in this, and we want to carve in the letters. Now for the G-code tools, we start with orientation points on the carve in layer. So just click on apply, and they will arrive at the lower end of the page. And what they are, what basically is the 0 point for the milling operation, and further to the right, I think this the 10 centimeter point. So you see that this is close to the edge now, so I know that when I place my milling tool here later on, I'm milling into a square where the sign fits in. So a very important setting is this one here. This decides how deep the drilling mill goes into the object. And it's just the surface of my copper plated board, so I guess it's probably 0.3 millimeters. For the cut through, I have to cut deeper, and so we also apply orientation points to this layer. And now I have to align this as precise as possible to the other layer. So, and we do this as precise as we can. Okay. So the cut through layer has this value still in default, and I set it to -1.5 because my copper plated board has a thickness of more or less 1.5 millimeters. Alright, now we can add a tool, which is just a cylinder basically. The feed rate is important, and I set it to I'd say 40, which is 40 millimeters per minute. And let's set this to 60, should be good enough for drilling into the tool. So the feed is the sideways movement, the penetration feed is the z-axis movement. And we just copy and paste this tool to my most upper layer here, so that I have orientation points and a cutting tool in both of these layers now. We mark all the paths that we want to convert into G-code. Go to G-code tool, path to G-code. Now there's some options here that I want to explain. The scale along the z-axis would put a certain multiplier to all the z-axis coordinates, which I don't do, so it's just 1. And the offset along the z-axis is basically how high is the tool above the surface at the beginning. So I have this value to 0 because when I start milling, I just have the tool touching my workpiece already. And then I click on path to G-code. This is important, if not, the apply doesn't really work. And press apply, and it should not give any error messages. That's good. And now I have my little logo here as G-code path, and we can take a look at it. This software here is OpenSCAM, one of the most useful pieces of freeware software when it comes to CNC milling. It can take a piece of G-code and simulate the milling process. So I'm opening the file that I did in Inkscape, and now I have to change some parameters here. This is the drilling tool diameter, and I decided to use a 1 millimeter drilling bit to mill that. And also you can see that this is where the G-code is milling, and this is where the work plate is right now. So I have to change some parameters of my work plate. It's going to be 1.5 millimeter thick. Now I have to shift this work plate at the same level where my action is. And I do this in a way where the deeper lines will cut to the object, and the surface carving just goes a little bit into the object deepness. Then I can press recalculate, and it will calculate how the object will be milled. This actually looks pretty good, but there are some difficulties that might appear and that we have to avoid. First of all, the edge here is really thin, so this might break apart in the milling process. Also, I want to actually have this edge as even as possible and in general thicker. Second of all, my letters are relatively close to each other for having a 1 millimeter drilling bit. So it would look nicer when it would be a little bit more apart from each other. Third, this hole here might be too small. We want to put a keyring through there or something, so we might want to have it a little bit bigger. And then, before I moved the plate, I saw that there's only two lines cutting through the material and one line for carving. So I might have set the deepness step wrong in the Inkscape plugin, because I want to carve 0.5 millimeters at once, which means that I need at least three deepness steps to cut through the whole material. I've changed the necessary details in Inkscape and recreated the G-code. And I will open this now. In general, it takes probably 8 or 10 iterations of G-code creation and checking before an object is looking really good. And you should take this time. You know, the software helps that you don't mill stuff that doesn't work at the end. It helps avoiding a lot of mistakes. And again, I have to set the tool to 1 millimeter. And here we go. So now we see that the letters are a little bit further away from each other, so there is less danger that these edges get broken. Then we see that the edge is thicker than it was before and more even, and we see that the hole has gotten bigger, so I can actually put a keyring through that now. And now I can start milling. I attached the board for milling to a piece of wood. You can see that I used it before for my little skull here, and now I am using the leftover surface. The board gets clamped to the milling bed. My experience shows that using a strip of wood and 2 painter's clamps works fine and ensures that nothing slips. My drilling tool is made from a 1 mm sewing needle, which I have cut off and then ground away half of the tip. The inner edge is shaped a little bit with a Dremel until it is more or less half-moon shaped. Such a milling tool works surprisingly well, although it might not survive for very long. I am using the manual keypad to position the drill so that it exactly touches the surface of the workpiece. Then I am going 1 mm up. I am moving some centimeters forth and then up and back and down, just to check that my material is enough and nothing is in the way. Then I lower the tip again by 1 mm and I'm almost good to go. The vacuum hose gets attached to the machine and put close to the tip. I am switching my machine into external mode so that I see in the display what the computer sends. Switching on the Proxon, switching on the vacuum cleaner, and off we go. The mill starts with the hole and the outline. Do you see a problem coming up? I do. Damn it, I have to cancel that and switch off the power to the motors. The problem is that when the outer line is milled first, the inner part gets loose and I cannot carve into it anymore. The solution is splitting the jobs. In the gcodetools in Inkscape, I create 2 files now, one for the outline and the hole, and one for the letters and the inner line. Now I can send the files individually. Back to milling. Do you see that little hole down here? This is where the drilling tip was at the very beginning. I did not move the piece on the workbed, so I can use that hole to reposition the mill. I used the manual controls for that and placed the drill as perfectly as possible over the hole. Then I sent the file for carving. I have also set the milling speed a bit higher, to 1.3 mm per second. You can see that the mill can do that with ease. I could go even higher, but more speed also means more stress for all the components. When the carving is done, I can send the second file. The mill starts with cutting out the hole again. Of course, it doesn't know that it is already there. Then the outline starts, with 0.3 mm in each go. The whole cutting process takes 7.5 minutes. The drill has cut through almost perfectly, with just this little edge holding back the piece in the plate. The edges are already pretty clean and there's only little residual copper that I can scratch away with my fingernails. After some polishing, the logo is finished and now I can find a keyring for it. I engineer things since quite a while, and still, with building that machine, I learned a lot of new things about electronics, mechanics and programming. And now, by having the machine, the way I develop things will change, because when I have designed parts in the past, the question always was, can I build it? And now the question can be, can I draw it and then let the machine make the object? This opens a whole new bunch of possibilities. My little CNC series ends here. I will do some follow-ups occasionally that explain further details. For now, thanks for watching.